Assalamualaikum and hi everyone, my name is Aqilah and I am a Material Science and Technology student from Faculty of Applied Sciences, Universiti Teknologi UiTM. In this video, I'm going to talk about my final year project during my degree studies entitled Synthesis of Graphene Film from Industrial AYAMAS Waste Cooking Oil. Alright, these are some of the contents that will be focused in this presentation. Without further ado, let's jump straight into the first part in this project, which is the background study. Alright, this is the first section of this presentation, which is the introduction. Before I explain detail about background study, let me explain to you guys what is actually graphene is. So graphene is the thinnest material ever found, and this material is very transparent, highly flexible, and then possesses excellent mechanical, thermal, optical properties. So basically, this material has been applied in almost various applications like touch screen in smartphone. Like I'm holding right now, the touchscreen of handphone is mostly made of graphene, and then energy storage like supercapacitors, and also in medical devices like biosensors. Alright, for background study, today many researchers have a necessity to make graphene out of waste. Many previous studies have enjoyed great success in producing high quality graphene. So basically, in this study, graphene film is synthesized or produced using waste carbon source, which is waste of industrial cooking oil or WICO by thermochemical vapor deposition method (TCVT). Basically, we wanted to produce graphene film from waste carbon source, which is industrial waste cooking oil, using a method known as thermochemical vapor deposition method. Here, the waste carbon source was obtained from food processing industries, AYAMAS Food Corporation's Berhad. The samples of graphene were prepared using different volume of carbon source, WICO of 30 microliter and 50 microliter. And then the samples of graphene were characterized using characterization techniques of Raman spectroscopy, field emission scanning electron microscopy, and energy dispersive X-ray EDX to study the morphology and structural properties of graphene. Alright, next we move on to the problem statement of this research. In this section, there are three main problem statements arise in this research. The first one is the abundant waste of WICO or waste cooking oil from food processing industries has created major disposal problems that contribute to environmental problems. For instance, pouring the waste oil into the kitchen sink will cause blockage due to solidified oil. Next, WICO is usually discharged straight into the river will cause water pollution. Thereby, this action is actually affecting the aquatic life. And then, the second issue with WICO is that the waste cooking oil is harmful for human consumption. The waste oil or WICO cannot be used anymore for cooking after repeated or frying or cooking. This is because in some studies, there are studies that reported that consumption of waste cooking oil can cause health problems like atherosclerosis and cancer. Lastly, previous carbon sources for synthesized graphene are toxic, high cost, and not readily available. Previous carbon sources like acetylene and methane are toxic and high cost. Besides, carbon source like pristine oil can produce high quality graphene, but the carbon content is less as compared to WICO. Next, we move on to the research objective. This study is aimed to achieve three main objectives. The first one is this study is aimed to produce graphene from waste of industrial cooking oil, AYAMAS, as the carbon source using thermochemical vapor deposition method. Secondly, we wanted to identify the optimal volume of waste of industrial cooking oil AYAMAS is producing a multi-layer of graphene. Last but not least, we also wanted to study and characterize the morphological and structural properties of graphene using field emission scanning electron microscopy, FESEM, energy dispersive X-ray EDX, and Raman spectroscopy, respectively. Here we move on to the next section, which is literature review. Alright, these are some of the contents that I discussed in my studies about graphene film. For literature review section, I will focus for the various types of carbon sources used to synthesize graphene. There are three types of carbon sources that enjoy great success in producing graphene, which are palm oil, waste cooking palm oil, and waste chicken fat. In previous studies, graphene made from palm oil exhibit high optical transparency of 80%, and good electrical conductivity. Besides, according to previous study, waste cooking palm oil is the best carbon source to replace toxic and harmful carbon sources like methanol, ethylene, and ethanol. Lastly, it is found that waste chicken fat also can be used as an alternative carbon source to make graphene. The graphene made from waste chicken fat is found to exhibit excellent mechanical and optical properties. Next, let's jump into the methodology section. For the experimental method, the parameter to synthesis graphene composed of the volume of industrial waste cooking oil, or WICO, the temperature of the precursor and substrate furnace, and also argon gas flow rate SCCM. Here, the sample will be prepared using two different amounts of carbon source of 30 micronliter and 50 micronliter. As you can see here, this is the flowchart in synthesis graphene. The first step in synthesis graphene is the substrate cleaning. Here, the nickel foil is cleaned using chemical and the ionized water in a sonicator bath to remove any residue and contamination. Next, we place the waste cooking oil and nickel into two different alumina booths. Then, the nickel and waste cooking oil are inserted into substrate furnace and precursor furnace. This is the TCVD furnace setup. Here, the formation of graphene film happens during synthesis process in TCVD system. Both WICO and nickel will be heated at very high temperature. During the synthesis process, the carrier gas, argon gas, will carry the evaporated oil into substrate furnace to collide with nickel substrate to deposit a thin film. After the process is done, the sample will let cool for several hours. Lastly, the samples are characterized using three types of characterization techniques, which are Raman spectroscopy, FESEM, and energy dispersive X-ray EDX. Next, we move on to the results and discussion. Here, the results from characterization techniques of Raman spectroscopy, field emission, scanning electron microscopy, and also energy dispersive X-ray EDX will be discussed in this section. Raman spectroscopy is helpful for determining the graphene layer. So this figure shows the Raman spectra of graphene grown by CVD using different amount of carbon source WICO for sample 30 micronliter and 50 micronliter. For the graphene grown by TCVD method, the number of graphene layers is determined using the ratio of intensity of the 2D peak to the intensity of G peak, I2D over IG. As you can see in the table here, the ratio of intensity ratio of the 2D band to the G band, I2D IG of 30 micronliter is 0.43. So the value of 0.43 here indicates the metal layer graphene having 4 to 10 layers. This is said by looking at the ratio of the 2D band and G band. Indicator having less than 1 is actually metal layer graphene. And then, meanwhile, for 50 micronliter, the I2D over IG value is 0.36, indicating a formation of graphite. That is, having graphene layers more than 10 layers. In previous studies, the lower values of I2D over IG, the lower values of intensity of 2D or over IG, the higher the graphene layers. Alright, next we move on to the results and discussions of field emission scanning electron microscopy FESEM. So in this section, we want to study the morphology of the graphene samples. And then, okay, these figures shows the FESEM measures at magnification 5000 of produced graphene on the nickel substrate using different amount of carbon source WICO of pure nickel, 0 micronliter, 30 micronliter, and 50 micronliter. So, figure A or figure of pure nickel has shown the surface morphology of pure nickel without introducing carbon source WICO. In B, the FESEM image of graphene film with carbon source of 30 micronliter has clearly shown hexagonal shapes of graphene and display darker contrast with crumples and wrinkles on the sample. So we can see here the darker contrast and hexagonal shapes revealed indicate the multilayer graphene. Meanwhile, when the amount of carbon sources increases, sample 50 micronliter reveals the thicker graphene sheets, responsible for high number of graphene layers grown in comparison with smooth and flat surface of graphene film produced from 30 micronliter, as observed in B. FESEM image of sample 50 microliter Wico reveals a uniform color contrast that is lighter compared to the multilayer graphene formed with 30 microliter that we can see here. Alright, so here we will discuss the energy dispersive X-ray results. So the EDX spectrum results reveal the typical element of carbon, nickel and oxygen present in the samples. So the EDX analysis in sample A of pure nickel shows the presence of carbon and nickel with high nickel content with weight percentage of 97.70% nickel. And then here in sample B with 30 microliter of waste cooking oil, the sample with 30 microliter Wico has the highest carbon content with 88.49%. And then from the table, we can see the carbon content of 50 microliter Wico has decreased from 88.49% to 20.26% carbon. This is because further increasing the amount of waste of industrial cooking oil Wico to the substrate resulted in the low carbon atoms deposited onto the substrate. From this EDX analysis, we can see that the carbon content of 30 microliter Wico is the highest, which is 88.49% compared to other samples. Okay, the last section of this presentation is the conclusion and recommendations. So for the conclusion, we can conclude that graphene film was successfully produced and synthesized using waste of industrial cooking oil Wico as waste carbon source by using thermochemical vapor deposition method. Secondly, the optimum volume of carbon source Wico to produce multilayer graphene by TCVT method is 30 microliter based on the significant results revealed by Raman spectroscopy, FESEM and EDX. Lastly, we can conclude that the morphological and structural properties of graphene were successfully characterized using characterization techniques like Raman spectroscopy, field emission scanning electron microscopy, FESEM, and energy dispersive X-ray (EDX). Alright. This is the summary of the conclusions. So in Raman's analysis, the graphene film produced show a relatively value of intensity ratio of the 2D band to the G band I2D over Ig of 0.43, which is less than 1, indicating the existence of multilayer graphene. Next, for FESEM characterization, the amount of industrial cooking oil with 30 microliter revealed that darker contrast with wrinkles and crumples on the surface of the nickel substrate represents the multilayer graphene. Lastly, the energy dispersive X-ray EDX show that the carbon content with amount of carbon source Wico at 30 microliter have the highest carbon content of 88.49%. These are some of the references used in this presentation. Alright, that's all from me. Thank you.